The genetic variation of the novel coronavirus now dominating the world is infecting human cells more readily than the original that emerged in China, at least according to new studies. The research suggests the mutation replicates faster, which means it may be more transmissible. Professor Neville Sanjana is a geneticist at the New York Genome Center and also New York University. Professor, thank you very much for your time. Good to talk to you. I think all viruses mutate, don't they? Why is this significant? Why is it a particular worry?
Yeah, that's exactly right, Mike. All viruses do mutate. I think the reason why this is a worry, and this mutation that we're talking about today, is a mutation in the spike protein. And the spike is kind of the thing that sticks out from the virus. It gives coronavirus its name. It is the corona of it. And the reason that this particular mutation is worrying is that we and others have found in laboratory experiments that this mutated form of the virus more readily infects many different types of human cells.
So the new mutation, if I understand it right, has a strong spike that doesn't break when it tries to infiltrate cells.
Yeah, that's a good summary. We looked at many different possible mechanisms for why this is, and it's still not, I would say, completely clear as to how this very, very small change in the spike protein leads to this increase in infectivity. But the increase is unmistakable. So we looked at cells from the lung, from the liver, from the colon, so many different human cell types. And across all the cells that we looked at, we consistently saw between a 2- and 8-fold increase in infection. That's not small numbers. That's quite a large increase.
And I think increasingly we're seeing research suggest this is not so much anymore a respiratory disease, something that particularly attacks the lungs, but it's becoming a vascular disease, attacking all parts of the body that rely on fine blood vessels. What are the particular moves in this virus that concern you most?
Yeah, I mean, this is, I think, a big unknown right now, which is why we made some efforts not just to test when we looked to see the original strain of the virus and the one with the mutation. We didn't just test it in one human cell type. We looked at many cell types because we are worried that the virus doesn't just affect one organ. In fact, one of the, I think, hallmarks of COVID, right, is, or one of the first symptoms that people often report is a loss of smell. And so that tells us that the virus is likely getting into olfactory neurons that are involved in smell. But of course, it's not just neurons, but many other cell types in the body. And I think this is a really active area right now to really understand, are all cells impacted equally? And how is there treatment that needs to be different depending on where the virus moves within the body?
I suppose it's not much comfort, but I suppose if a virus becomes too deadly, it dies out eventually because it has no more hosts left, no more of us. Do you think we will find a way eventually to live with this?
That's a really good question. I mean, I think it's, this is kind of natural selection in action. If a virus, as you said, is too deadly, it's not able to spread. There are many viruses that spread, common cold. HIV is another virus that can spread, but are not perhaps as deadly as coronavirus. And so this virus does seem to have kind of found this perfect middle region where it is both quite deadly, but maybe not too deadly, or relies on a lot of asymptomatic spreaders or super spreaders, while still being, having a tremendous impact, causing a global pandemic.
I'm not sure that's a comfort, but it's interesting and it's useful. Professor, thank you very much.
You're welcome. Thanks for having me.